So thank you very much. We're pleased to be here today. This is the Advancing Technology panel. And we're looking at a 25 gigawatt ambition just in this one state. So it's an opportunity for technology. Floating, we do have a couple of commercial developments on the way, but probably the mature technology in large scale is not going to look exactly like those. So it is a time when we have competing designs and a lot of discussion about even the basics of what floating offshore wind will look like. There's also, besides just the kind of overall structure, there are many components here that have not been part of the fixed bottom offshore wind world that the Europeans have developed so far already and is already being commercially deployed on the East Coast. So it's an opportunity for new technology to be thought through and developed and deployed in a way that we haven't seen in the same way on the East Coast in the US. So we have a panel today. Very pleased to introduce myself. I'm Willett Kempton. I'm a professor at the University of Delaware. I work on offshore wind and also electric vehicles. We have Alrayes, Senior Manager of Business Development for Vineyard Offshore. Aubryn Cooperman, who is an engineering analyst at NREL, the National Renewable Energy Lab. Mike Olsen, who's Vice President for Strategy and Partnerships of Renewables in the US for Aker Solutions. And Aaron Smith, who is Chief Commercial Officer at Principal Power. So among us, we represent companies and individuals who originate technology, but also who are consumers of technology, as well as analysts. So we have these different perspectives in regard to technology. So I will start out with questions that we have prepared to start the discussion going. We expect to have time for audience questions. We've left time for that. And to enter questions, that's going to be done, as with the other panels, through the app. So you open up this panel, and then from this panel, you are able to enter a question, which will be moderated and we'll see up here. So I'll start with the first question. This is the Advanced Technology panel. So let's start by asking what technologies are still needed to deploy floating offshore wind. That's what we're talking about here in California. But of course, this may apply, it does apply elsewhere, and perhaps technologies developed in California will be used elsewhere. So we have the turbines, right? Turbines are already known. Are we just deciding how to float the turbine, or is there more to it? I want to start out by asking Aaron to answer that question.
Sure. Thanks, Willett, and thanks all for being here today. It's really a pleasure to be back in California. So my name is Aaron Smith. I'm the Chief Commercial Officer at Principal Power. We are the designers of the wind float technology. So we've been able to deploy that in Europe over the past 12 years with about 75 megawatts operating in Portugal and Scotland and 30 megawatts under construction in France, then a global pipeline of projects, including in our home state of California. I think, Willett, you hit the nail on the head by starting with the wind turbine. The point of floating wind is to be able to deploy wind turbines in water depths that are previously inaccessible, which includes the swath of the California coast that we're all interested in today, as well as the broader Pacific. And I think what's really important for us all is that this industry of offshore wind has a 30-year track record where it's been proven that we can produce these turbines at industrial scale, make them work very well. They're bankable, they're insurable. They're scaling quite rapidly right now, and that's a debate we can touch on later in the panel. But that is really the core. So how do we plug in these very commercial and available wind turbines into a new environment? So then we go to the platform technology. For ourselves, with the track record that we have, we've proven that we can produce power in a variety of site conditions. We've proven that we can deliver the projects, we can make them last for the design lives that need to be achieved to make these projects commercially viable. And the real next step is how do you translate them to the new environment in the Pacific where we have much deeper water, and also how do you deliver at industrial scales, which so far the projects that we've been involved in have not required that sort of delivery, which is basically, think about one per week for structures that are somewhere around 3,000 tons and in a supply chain that really doesn't exist here in California. So what we're really laser focused on is how you take a design that is proven that we know works and develop the supply chain around that, make sure it's compatible with the supply chain. And as a designer, our view is that the focus needs to be on modularity and flexibility to make sure that we are able to comply with different types of ways that the supply chain can evolve here in California. We do have a partnership with Aker Solutions where we're working on one of the DOE flow-in prizes to advance that, and we're exploring different types of scenarios. And I think in this whole innovation environment, a lot of how it evolves depends on the market context that the government sets, that's state and federal. We need to make sure, there's options, right? You can either build things modularly, import them, assemble them here, and do it kind of project by project, or you can go after a scenario where you really have an industrial plan to build an industry here in California with the sort of certainty on volumes and procurement timelines and leases that enables people to really invest in a supply chain here. Our view is that the real prize in terms of cost reduction, in terms of meeting these very aggressive targets that DOE is setting, is to try to do as much as possible here in California, but we really need policymakers to give the environment to justify investments in new facilities that are really purpose-built for doing these units. And I think the other aspect, and I'm sure I'll hand it over here, but commercial projects do carry a different set of requirements. So here in California, we're going to need to apply many of the deepwater mooring technologies that have been common in oil and gas. So we don't see technical hurdles, but certainly there is a de-risking process that's going on there. One of our projects with NREL is called Deep Farm, and we've been working on that. And then other aspects are, big projects require substations, big projects require higher voltage export cables, and those demands go beyond anything that's ever been demanded by an infrastructure projects built by humans before. So taking that step towards commercial scale for us is the real leap that we need in terms of technology.
Mike, how would you add to that or contest Aaron's perspective here?
Me?
Yes, Mike.
Right.
On what technologies
We just go down so first off, Mike Olsen again with Aker Solutions. We are not a developer of offshore wind projects, but we build things. So company gets a lease, gets its permits, contracts with Aker Solutions to do studies, to do engineering. We've been involved in many offshore wind and oil and gas projects. In fact, our longest history is based on development of big energy projects in harsh environments and so forth. So we have a history in oil and gas, which I think is very important. So Willett, you asked the question, is the technology there? Do we just put the turbine on the foundation and are we ready to go? I think it's important to note that the technology is there by and large. It's proven. Equinor has deployed a spar for its projects, Principal Power with the Kincardine project. So the semi-submersible, the spar, is based on and patterned after and engineered from technology that has been in use for oil and gas for years and years. And I think it's important that we are approaching this industry from the standpoint of technology that is proven. But at the same time, I think there's a need to, and there are ongoing efforts to improve on that technology that exists and that is proven. For example, mooring systems are very important for floating offshore wind, essential, in fact. And the industry is looking at opportunities for reducing the number of either mooring lines, but more specifically, I think maybe more likely anchors. So let's say, for example, you have a semi-submersible floating structure with, let's say, 6 mooring lines and 6 anchors coming off of that structure. We have developed a technology at Aker Solutions that we call the V-share, which essentially would take that same number of mooring lines and bring them, 2 of them to one anchor. And so the name V-share comes from, if you were to look from the surface of the ocean down, you would see V-shaped mooring lines to an anchor. The benefit of this is several-fold. Fewer lines, mooring lines spread out in the water, which then can result in, of course, fewer conflicts. We talk about and hear a lot about secondary entanglement of marine life resulting from the entanglement of fishing equipment. So limiting that space where mooring lines are spread out is important. There's improved platform motion as a result of this technology. Reduced number of anchors, as I mentioned, reduced mooring and footprint. So this, again, technology that has been developed and used before, but shifted and changed a little bit to improve what we're trying to do to make what we're doing better. Another thing I would just touch on, and we can come back and talk a little more in detail, subsea substations is another thing. Again, developed for oil and gas, has a number of different benefits: reduced cost, reduced maintenance, because of the reduced maintenance, it's subsea. You don't have to worry about safety issues that you might otherwise worry about with people coming and servicing these facilities. So again, technology that has been used before, but is being adapted and used and developed for floating offshore wind to make what we're doing more efficient, less expensive, and better.
Thanks. If other panelists want to add, Ken, or we'll move to the next question.
Say again?
Other panelists want to add, or we'll move to the next question otherwise?
Sure, yeah. I think from our perspective, the focus on, and hello everyone, good to see you again. My name is Alrayes. I work for Vineyard Offshore in the business development team. Vineyard Offshore is very excited to be the provisional lease winners for one of the Humboldt sites. And we're very excited to be able to explore the technology together with our future partners here and bring floating offshore wind to California. And through our experience to date and through our parent company's experience doing floating offshore wind and working on developing projects internationally, I think we've learned quite a bit about the technology and how we can get to where we want to go. I think the focus on foundations and the platform is great, but we do need to sort of take it a next step, like our panelists were saying, with the scale-up. We've done demo projects internationally, but it's important to note that floating offshore wind has not happened at commercial scale anywhere in the world. And we need to be able to prove that these floating foundations can scale from the 5 megawatt range of demo projects up to a 15 megawatt range that we need to in order for our projects to materialize here in California. And that's not just on the engineering side of things and adaptability of the design, but also on the industrialization and manufacturing. Can we make enough of them at that scale fast enough such that we can deploy the projects is a critical question. Outside of the foundations, I think there are critical elements that we need to explore together as an industry around the viability of high voltage dynamic cables. At waters this deep, no other floating offshore wind project is really proposing 1,000 meters of water depth. And we need to explore together with industry how can we get floating cables to work in that kind of environment. And along with floating cables comes floating substations. Those two work hand in hand, or undersea substations like Aker Solutions is developing. But we need to figure out how all these systems come together, which really then presents the role of floating offshore wind requires large-scale integration of systems, not so much as we see in fixed bottom, where the different packages can be designed in isolation from each other. But as a developer, we really value the ability to design these systems in integration of each other, because the turbine ultimately affects the floating foundation, which ultimately affects the inter-array cables and the mooring and anchoring system, which then affect the floating substation. And we need to look at this as an entire package of technological development.
Ollie, thanks. So Ollie's starting to bring up the question of scaling and size. So we can think about maybe the first few projects in California, maybe a total of 2 or 3 gigawatts. Total leaseholding, I've heard the number 9 gigawatts, I guess, from the first panel. But how do we get the first projects out? Do we have the supply chain for that versus that full 25 gigawatts? What kind of supply chain is needed for that? Maybe these are different. So a lot of times technology people think about design, and designs are great, but obviously to build projects, you need a supply chain, and you need to be able to produce at a time that the developer needs to put the pieces together and build the project. So what are the most pressing supply chain needs? And Aubryn's thought about this a bit. I'll start with her.
Yeah, thanks, Willett. Hi, I'm Aubryn Cooperman. I'm a techno-economic analyst at the National Renewable Energy Lab. And yeah, we've certainly identified the supply chain as an area where there's a lot of work to be done, and sort of a lot of possibilities, ranging from a scenario where supply is really coming from a variety of global locations, and there's very little manufacturing and assembly here in California, versus a scenario in which there's a lot more job creation in the supply chain here in California, and having that local content. So there are various pathways to this. We're really trying to look into this. In one way that we're looking at this is the DOE's Flow-In Prize, which is in cooperation with a number of different companies, and looking at some of the manufacturing and supply chain challenges that are specific to these companies and to the U.S. manufacturing and supply chain opportunities.
Great. Other panelists want to add to that?
Well, I'll chime in. I think consistent with what Aubryn said, it is, I think, going to become, it already is important, but becoming more and more important that we consider local content and the ability to develop a supply chain locally, whether that's because developers want to, and others want to be able to take advantage of the provisions in the Inflation Reduction Act, because local governments and state government officials want jobs in their districts or in their cities or in wherever they are. And as we've heard from many of the panelists yesterday, this is an important industry. People want to be involved and so forth. So I think, and consulted and participate in the planning and the success. So we need to, I think of of opportunities for the development of local supply chain. So again, just another example, concrete. As we're considering development of floating structures here in California, is concrete for purposes of for constructing foundations, is that an option? Would that provide opportunities for local content? Could it make it easier to build these massive structures? There's, again, a long history of concrete in oil and gas, floating structures. Hywind Tampen, again, to mention Equinor's project that we were involved with, is a spar buoy concept, but it is concrete. So I think looking at those opportunities, maybe being creative, could help with the development of the local supply chain.
I think, again, totally agree with what you're saying, Mike, but here we have a part of our panel titled Cost Reductions, right? And how are we going to achieve cost reductions, and how soon is a question that I know DOE and CEC are asking quite a lot. We're all asking ourselves quite a lot. we see that the biggest single source of cost reduction for floating offshore wind right now is in terms of scaling, in terms of standardization, in terms of optimization of the supply chain. And that there is going to be a huge jump going from the small commercial projects that we have operating today to the large commercial projects that we have that are a gigawatt or more. And our kind of the trade-off that we think exists between importing things and building things locally is in terms of both what really comes down to the timelines that we have and the certainty in those timelines and how procurement is structured at the state level. And what we really encourage the policymakers here in California to do with procurement is to not try to turn the crank on cost too soon. Try to really think about the industry that you want to build here and use procurement, especially the first rounds of procurement, to incentivize those type of value drivers that you want from a long-term offshore wind industry. If you go ahead and you run a least cost procurement process where you're just having developers compete to see who can deliver the lowest margin, and great deal for the ratepayers, but then you get people that are taking a lot of risks. First, the developers are coming in and they're really compromising on their margin. But then they're doing so because they think they can push the pressure down to the supply chain. So then the tier one suppliers have to compete to go to these projects, and there's a limited number of projects with procurement contracts. They also need to bid with very low margins, and they bid aggressively with the expectation that things will change and maybe they can recover some of those margins. But then you get further down into the supply chain, into your tier two suppliers, your tier three, and that cost pressure just percolates down. And we've seen, that approach in the UK has not been able to really drive the development of a real supply chain. So most of the components in the UK are really coming from Europe. They've done better recently as they've recognized this and as they built more scale in their industry. But California has the opportunity to avoid that sort of boom and bust cycle by focusing first on building a stable, deliverable foundation for an industry that really has the domestic content, that really allows the workforce to develop and for us to learn as an industry, and then use the subsequent auctions as you go towards the, from 5 to 10 to 20 gigawatts to really turn the crank on the cost reduction. Because we know that offshore wind can be a least cost source of energy, but it does take time to develop, and you don't want to make decisions in this industry on a project by project basis.
And to Aaron's point, I think what is critical is that we get clear and consistent market signals.
Yep.
I think for partners to come and want to invest in California to industrialize, we need certainty towards a path that we can achieve those investments. I think a great example of that is the maturity of the fixed bottom offshore wind industry on the East Coast. There's a great example of standardization that happened around the world where fixed bottom offshore wind started with these structures called jackets that are very one-off, custom designed, and very quickly matured into a standard design of monopiles that can be fabricated in a large manufacturing facility. And just a few weeks ago, the day before the IPF conference, I was at the US's first monopile manufacturing facility in New Jersey that is producing monopiles for fixed bottom offshore wind projects on the East Coast. And so what happened there is that the technology standardized, which I'm sure the industry will eventually get to through global projects, but the clear market signals on the East Coast were there. The procurement was clear, the permitting was clear, and the path to interconnection were clear. And we need to achieve that here in order for partners to come and invest.
Mm-hmm.
Yeah, thanks. Those are great comments where showing when we're talking about advanced technology, it's really not just the engineer sitting in the room with the paper. It relates to procurement, standardization, consensus about how we're going to do this. And then that raises a question, which is, how do we know when it's the right time to standardize versus we maybe haven't picked the best design now? I have a very smart colleague who's been telling me since we were installing 3 megawatt turbines that we need to standardize on the current turbine size. At that time it was 3 megawatts, so that we can get the advantage of scale and mass production. And as I recall, he said the same thing when we were at 5 megawatts and at 10. But and I think some of you know who I'm talking about. He's a really smart guy. So when do we decide to standardize? And when do we say, well, we're not quite there yet. We should do this new design. This is going to be better. You know, look at what my CAD model tells us. As developers and customers of technology, or as producers of technology, how does your company decide it's time to standardize? And we want to get everybody on board with this version. Start with Ali.
Sure, yeah. I think as customers, as you put us, or developers of the project, we see this sort of race for larger turbines, and it's no secret. And the floating foundation providers have to keep up with that. But I think we're at a point in floating offshore wind that the momentum globally has developed to a point where there will be projects that will be deployed at the large scale, 15 megawatt, maybe 10 megawatts or so of turbines, before we get to identifying some of these issues in California. Some projects are on the cusp of large-scale deployment. And so when we evaluate these technologies as a developer, we're really looking for a few things. We're looking for, is the design engineered for manufacturing such that it's easy to build on site? Or is the design engineered for assembly? Or is it something that can be assembled together but difficult to manufacture? Or is the design engineered for operations? And those can be competing factors, but I think collectively we have to evaluate sort of the technologies that we choose on all of these factors to some extent. And then sort of let the technology mature through the supply chain activities that we keep talking about, such that we eventually coalesce around a single design.
I think just to come back to what I was saying before, you know, the technology for the development of floating offshore wind exists. And I like the way, Ali, you put that. Are we engineering for, or are we designing or engineering for manufacture? Are we designing or engineering for operations? And I think, you know, and I don't want this to be taken as, you know, this is not Aker Solutions' endorsement of any particular technology, so I'll just put that disclaimer out there. But there are 105, 110 concepts, floating foundation concepts under development, or that have been or are being tested or have been tested and proven. And each one of those, give or take, is designed for traditional, what we would consider traditional horizontal axis turbines, which is great. But then there are other companies or other designs, other designs that are either being developed, worked on, or that have been tested that are not what you would consider your traditional horizontal axis turbine, and are being developed specifically for offshore. And I think it will be interesting to see as the industry develops and as the industry progresses, whether any of these technologies, like Hexacon, for example, which is they have their patented twin wind, which is 2 turbines on one floating foundation. Worldwide Wind is another one that has a counter-rotating vertical axis turbine, both of which designed and developed specifically for floating wind. Again, this is not an endorsement of any particular technology. I just think it's interesting and something we should be thinking about as the industry progresses, that there are developments and technologies that are being worked on that are being developed with having the principle in mind that this is floating wind and this is not land-based wind, and maybe we ought to be thinking about putting structures out there that are specifically designed for floating conditions. That's not to say that the principal power design is not awesome, or that Equinor Spar is not awesome. I mean, they work great, but looking at these other opportunities, I think, what are we engineering for? What are we designing for?
So, Mike, you're contesting my lead sentence, which is we've already got the turbines.
Well,
Thank you.
we do.
I think
And I agree with you, by the way. That's a setup. So.
I think Mike's point is really interesting, right? We're at the very beginning of an industry that is going to deploy hundreds of gigawatts over the next 20 or 30 years. It's important to keep an open mind about what is going to work and what might not work, but it's important to do it very deliberately, right? We always like to say that we support and we continue ourselves to innovate quite a lot, but there's a difference between what we're putting in front of clients and what we're willing to take all the design risk on and everything versus what is in the R&D kind of side of our company. And I think that there's two tracks here, right? One track is we have this technology, horizontal axis wind turbines that have been proven, deployed, scaled up, bankable, insurable, globally, factories and supply chain to deal with these companies that are leaders in the industry and multi-billion revenue, can actually back commercial scale contracts. That whole industry stands ready to deliver on floating offshore wind as well as the fixed bottom offshore wind industry that they're working on today. There are other ideas, but those need to be demonstrated. They need to be put through their paces. Companies need to develop around those that are willing to back and put the guarantees on them to make them attractive to financiers like Ali over here. And I think that's a big difference. So we need to just separate those two tracks. We can standardize and industrialize the technology that we know works and make sure that it serves very well this kind of whole system, because floating offshore wind, it is a system. You can't have any one of those things, manufacturing, operations, power production, installation. None of those things can be a showstopper. You have to do them all well, and you have to do them 100 times in a row. That means no mistakes. And so you've got to have a very well-rounded system. So you can standardize and industrialize those aspects and build factories. And then as other innovative ideas become proven, they have the potential to displace those. But if they displace them in a situation where we built a supply chain, where we built the workforce, the safety standards, the environmental knowledge, and all these other things, then they can kind of come into that cost reduction trajectory rather than having to start their own cost reduction trajectory from scratch.
And I would maybe say that there's room for these two ideas of sort of innovation and standardization to play together. Mm-hmm. And that, thinking back yesterday, if you saw Chairman Hochschild's presentation, we looked at, by 1913, there were all these cars on the road. Okay, perfect. Cars have been standardized. That's what we all drive today, right? No, they've changed. There have been innovations within that, but those cars are driving on roads that, we're using this infrastructure that had to be built as well. And I think offshore wind is doing some of that. We are working with this design that is in some way standardized. The horizontal axis three-bladed turbine we see is as standardized, but there have definitely been improvements, changes in size, and just general innovation within that technology, but within a framework. And I think that as offshore wind moves towards floating, there's a lot of infrastructure that we've been talking about that needs to support that technology, and new innovations will both work within that infrastructure and innovate from a technology perspective.
Thanks. So we've been talking about supply chain, but part of the supply chain we haven't mentioned is the marshalling port, or in floating sometimes called the assembly port. So that's a big piece of the supply chain. But we're talking about maybe the foundations or even the turbine itself being quite different from what we've seen in fixed bottom. So do we have a concern that marshalling ports, which any large port should have a 30-year life? It's very low rate of return on ports. It's infrastructure, right? So if we're building ports over the next few years to serve the first few projects, are we building ports that will be obsolete as the turbine and support technology changes? So I know, Aubryn, you've worked on marshalling ports. Do you think we have a concern there, or is there some solution in mind for not knowing what we're going to be deploying out of those ports?
Yeah, so it's definitely a challenging question. I think there are a lot of different foundation platform designs, and they do have different parameters, different specifications. But I think we want to maybe think about an envelope of within which many designs fall, and where it makes sense to target these port developments. And can also remember that all ports are not alike either. So there's also room for particular platform designs to fit within specific ports and regions.
So I'm going to suggest we move to audience questions. There's several queued up here that I see. Let me start with the, we've been talking about technology in terms of deployment and manufacturing and cost of energy, but we haven't talked about, are there technologies that reduce wildlife impacts? And obviously with floating, we're in a different situation. You've got cables, maybe a kilometer of cable. How's that affecting the marine life in the water column, as well as other things? So do we have technology solutions for wildlife impacts, or do we not know how to do that yet for floating?
Well, not to sound like a one-trick pony, but I'll go back to what I talked about in the beginning. This shared mooring, V-share mooring system that we call it, given the way the mooring lines would be positioned, we think that yes, there is the potential for reduced impacts to marine life, whether that's by limiting the spread of mooring lines and limiting the possibility of secondary entanglement of marine life, or fishing equipment that may have become entangled in mooring lines. So yeah, I mean that is, I think, would be one example. I mean the reduction of the footprint that floating offshore wind will create in the ocean.
Other thoughts, Ali?
Yeah, from the perspective of developer, we think this technology is new, but I'd like to flip this around and say, as developers, we want to be partners in scientific research. And so if there's folks out there that are looking at utilizing the projects that we have and the technologies that we have to further pursue research into the impact on wildlife, we're definitely interested in that.
And we've heard, sorry, go ahead.
No, it's
My
okay.
bad.
It's a panel discussion. Discuss.
We heard too yesterday a good amount about monitoring, post-construction monitoring. These are massive structures. There's a lot of room on those things.
Mm-hmm.
There are opportunities to partner with organizations and others who could, we could put equipment, things on these floating structures for purposes of monitoring birds and marine life and other things. So there are significant opportunities, and we as an industry, we're not a developer, but of course we want to see the industry thrive, and we're all interested in the same thing. We need to make sure that we can do what we want to do without the impacts that are concerning to so many different ocean users. So any opportunity, I think, that we can to partner and to explore different opportunities, I think Ali's point is a great one. There are a lot of things that we can be considering for purposes of reducing wildlife impacts.
Mm-hmm. I mean, it all starts with siting, and I think that there's been a tremendous just learning from the development community, as well as all of the agencies that are involved in siting as they've gone through the process of selecting the lease areas, and for developers about how they actually go about developing the baseline data around these and making sure that they understand the species that are prevalent in wind farms. From our side, having done these projects in Europe, what we're focused on is getting good data to address perceptions, because I think that there are a lot of misperceptions about what the risks are with these projects. They are relatively innocuous. Of course, they are new structures in the space, but there's very little noise during operation. There's very little impact with the seabed. You have systems that are under tension, and so there's no risk of primary entanglement on these things. And so for us, we want to share the data from our projects. We also have a project that's under construction in France right now with Ocean Winds, who's one of the lease winners here. And that's the first floating offshore wind project in a marine reserve. So it's a protected reserve where we worked very carefully, mostly Ocean Winds, worked very carefully with the stakeholders there to make sure that we had a project that was as environmentally friendly as possible. And a big part of that has been going out and extensively baselining the data. We've deployed a buoy out there 3 years before the start of construction to monitor the different species that are out there. And we are running an experiment when we put the projects out there where we are installing fish nurseries on the floating platforms so that you can actually try to see if we can get or leverage the artificial reef effects of having these sheltered areas in the water to actually help fish stocks that are desired recover, and see if we can get I guess, an area that is going to be protected from industrial trawling to be something that can help our biodiversity in the oceans recover. So I think for all of us, we're environmentalists. We're tremendously concerned by the climate emergency that we have right now. We know that we need to do something, but we know that we need to do that responsibly. We have quite a lot of time here in California before these projects are actually deployed. We really hope that that's devoted to do the good quality collaborative research with everybody at the table so that we can get this industry deployed correct.
Thanks. So we had cost reductions in the title of this panel, and one of the audience questions is not going to let us forget that. They want to know what sort of technology opportunities are the biggest opportunities to drive lower cost of energy.
I mean, at risk of being a broken record, I think it's creating an environment where the supply chain can develop sustainably with predictable schedules and where people can actually make investments, right? We've got so many people that want to invest in the facilities, the vessels, the workforce that are going to be required to deliver this industry. And if they can do that in an environment that allows them to make the right investments at the right time without being worried about whether they're going to get any return on those investments across a few projects, I think that that's a huge responsibility. People often ask us, what does the Inflation Reduction Act do for your industry? And it does a lot. It means that manufacturing in the US is a real possibility, but it only works if we can get to deployment. And if we can get to deployment that gives people, because people don't invest on a tax credit, people invest because they got a tax credit and a revenue stream that justifies it. So for me, that's the biggest single source of cost reduction.
Yeah, I agree. I think we need to create an industry, a floating wind ecosystem here in California, rather than having 5, say starting right now, 5 lease areas, 5 one-off projects. So creating an environment where the industry can build and thrive, I think is important. I think it's interesting too that we're talking about cost reduction. How do we reduce costs from one project to another? Or on the East Coast, there with state solicitations, we hear about one solicitation comes out, companies respond. Next solicitation comes out, companies are supposed to come in with lower prices. I mean, we got to keep in mind we have no projects in the water. There is no steel in the water. I mean, other than a couple of small ones on the East Coast. So we got to have projects built, and we talk about standardization, and this needs to. We got to move this forward. It's tough, I think, to talk about in some ways cost reduction and reducing cost and price from one solicitation to the next when we don't yet even have projects in the water.
At risk of interrupting and continuing the discussion, I think we have a supply chain in offshore wind globally that's incredibly unhealthy. The biggest thing that can drive innovation, it's not necessarily more research dollars, it's a project environment that has enough revenue in it to support the innovators, right? We're a company that has been around for 15 years working on floating offshore wind, and we still have a challenging business case to make because the projects are so far in the future. Would we invest more in R&D now if we could? Absolutely. But everybody's running on very thin margins or making losses. That includes the turbine manufacturers, and we're asking them to scale up a tremendous amount and take the next jump in terms of capacity. So we need the projects.
I'm just going to break my role as moderator and say my answer to the question. I'm not sure how the question or minute exactly. You guys gave great structural and overall system answers, but kind of at the basic level, you want to move to materials that cost less if possible, and you want to have designs that require less operations and maintenance, and you want to build more in the factory and less on the assembly yard, and as little as possible at sea. So those are kind of fundamental things in terms of design to reduce cost of energy, which is another layer from what all you guys were saying. We've got a question from the audience that I think is good. It's we touched on this a little bit, but how do we reconcile the tension between standardization, which has all the benefits that we've talked about, agreeing on a design, ramping up, and optimization, which is this maybe somewhat different design, maybe very different design, given that we're at this early stage of market development, especially with floating? How do we reconcile that tension?
I think Aaron said it perfectly, that we're working with two tracks, and the governor here has made it also quite clear with two different goals, right? We have a 2 to 5 gigawatt goal in California by 2030 and a 25 gigawatt goal by 2045. I got those right. And so we need to do both at the same time. We can't be focusing on one and not the other. And so we have 5 lease areas. These need to be built. We need to submit something in our permits in the next few years in order to reach sort of go through the permitting hoops and eventually get consensus for these projects, just in time so that we can start construction and get something in the water by 2030. So that all needs to happen, and it needs to standardize, and we need to go ahead and move fast on that first track. But I think it takes important leadership not to drop the second track either, and continue pushing from the DOE level, for example, or like the flow-in prize that incentivizes sort of industry to think through the big picture and how can we go through the second phase of floating offshore wind. So I don't think we need to reconcile the tension such that they're competing with each other, but we need to do both and recognize that those are two different targets.
From my perspective, I mean, we're a floating foundation designer. The only reason we're in business is to support offshore wind turbines, right? And for us, the big challenge has been, we deployed our first unit at 2 megawatts. We then stepped up to 3 projects with 8 to 10 megawatt turbines. Went well, learned a lot, learned physics are different than at 2 megawatts, which is important in the stepping stone to the next generation of 15 megawatt projects that we're working on. And I don't know, are we going to deploy 6, 8, 15 megawatt turbine projects before we step up to 20 plus? I mean, the designs that are coming across my desk now for wind turbines are enormous. And, it's a great challenge. We've got a huge project ongoing internally about how we're going to address those. But it means that you have to do a lot of the kind of steps over in engineering to make sure you have the design that works, and that is a tension on standardization. So for us, we will follow whatever wind turbines you guys want to put on the floating platforms, but it does mean that there is the kind of same amount of engineering at each step level, and we will have to kind of learn and sort through new things.
Well, we are just out of time. I want to thank the panelists and encourage the audience to thank the panelists for our insights here. And thanks to the audience for staying and participating.
Thank you.